Okay, on this video we're going to work through one more example of a titration calculation similar to the last one, but in this case two things will be different. One, on the previous video we solved for the concentration of a base, and in this one we're going to solve and do number 10 where we're solving for the concentration of an acid. That's the first difference. And the second difference is that in this example we have an acid, HBr, that has one hydrogen in the front, which is kind of what we're looking for, is hopefully the case most of the time. But we have a base here in calcium hydroxide. Remember, the base is symbolized by this hydroxide group. And we have two of them. So for in this example, this calcium hydroxide has two hydroxide groups. And that means the acid and the base don't combine 1-to-1 in a 1-to-1 mole ratio. They combine in a 2-to-1 mole ratio. We're going to need two of the acids to combine with one of those bases. So what I want you to do with this one, and I'm going to have you do this one whenever you recognize this 2 is here. Okay, we've got a 2 in the end of this base. That's a dead giveaway that something's a little different on this problem. And spoiler alert, if you look down at the bottom of this page on number 13, you have an acid on number 13 that does the same thing. You have two hydrogens on that number 13 acid. That's sulfuric acid. Okay, and it's written here twice, but the same acid is involved here, and it's working with a base that has just one OH group. So on 13, you're also going to have a little different 2-to-1 ratio when you get there. But let's focus our time on number 10, okay? What I want you to do when you recognize that you have a base or an acid with an extra, like a 2 like that on it, what I want you to do is write the equation to show how these two things go together, all right? So remember, it's acid plus base, like before on number 7. Acid plus base gives us water and a salt of some kind. And so on number 10, our acid is HBr, so that's that. Our base is calcium hydroxide. And again, look for that OH group as a sign of a base. And when these get together, they always make water. That's H2O. And they make a salt. In this case, that's going to be calcium with the bromine to make calcium bromide. Now again, remember the reason this is the case with our 2 here is because calcium has a +2 charge, right? When it gets into compounds, and it does too here. Bromine, on the other hand, has a -1 charge, as it did over here. And hydrogen is always a +1. So when we get these together in the end, the hydroxide ion and the hydrogen ion make water. The calcium and the bromine get together and make calcium bromide. But to balance this equation, we're going to need 2 of these acid particles to go with 1 of these base particles. Now we're going to get 2 waters out of it and 1 of these. The key ratio, though, is this one right here. Okay, it's going to take 2 acids to go with 1 base. Twice as much acid to go with 1 base. In other words, this base is double powered. Having this 2 here means that this base is sort of double powered. And that's not a very scientifically official term, but our base has twice as much hydroxide as our acid has hydrogens. So that means our base is sort of boom, boom, kind of a double power. Okay, double strength Tylenol or something like that. So double powered here is going to have to come into play in our math as well. Now, speaking of the math, we're going to use the same equation that we've been using in the previous problem. That was Ma times Va equals Mb times Vb. And I'm not sure why I keep putting parentheses on those. You don't need to have them, but some people like to keep them there just to keep things organized. That's going to be the same here, but here's the deal. To show that this is a double powered base, remember, this base has 2 hydroxides, whereas in our previous one, the NaOH had just 1 hydroxide. To show that the base is double powered, we're going to take the base side of our equation. Remember, this is the acid side, this is the base side. Now we're going to take this side times 2. Okay, so this double powered base shows up right here. To show that it's double powered, we take that whole side of the equation and we double its power. Boom, boom. So it's going to be doubled up. And so to solve this, everything else is the same. Let's plug in what we know. It says you use 17.15 milliliters of 0.2500 molar base. That's our base. So that's going to go on the right side of the equation. Let me switch back to blue here. So the molarity of my base is 0.2500 molar. Okay. Let's slide this over just a touch. The volume of my base is 17.15 milliliters, again, given in the problem. And don't forget that too, to double that base side's power, all right? On the other side, we know that we used 63.5 milliliters of our acid. That's my volume, 63.5 milliliters used. And the molarity of my acid, Ma, is my unknown, so we're looking to find. And right there in the end it says, what is the concentration of the acid, right? So that's my Ma. All I need to do from here is rearrange like before. So I'm going to divide both sides by 63.5 milliliters, divide the other side by 63.5 milliliters, and like before, my milliliter units will cancel. Everything cancels off the left except for my MA, leaving that by itself. And if I plug that into my calculator, my MA should come out to be, let's see, thought I had this answer written down. I apologize. Apparently do not. Okay, I got it. The answer comes out to be 0.135 molar HBr. That's my acid. And again, remember to label your molarities with the acid or the base, as the case may be. Okay. So again, the key idea here is that because this base is double powered, I need to put a double power on the side of the base to show that moles of base, my MB and my VB together, get multiplied by 2 because every mole has 2 hydroxides. On the other side, essentially, we're sort of treating this as times 1 because my acid has just 1 hydrogen on it. So that 1 and that 2 from my HBr and from my calcium hydroxide come through as 1s and 2s here. But the key is just put a 2 on the side that's double powered. And in this case, that's the base side of the equation. And my molarity should come out to be 0.135 molar on the acid side. So label things out and simply divide from there to get your final answer. Again, every other problem on here follows these two examples pretty much to a T. The only exception being, again, number 13, where we squeeze in an acid that's double powered. And for that one, you'll need to put the 2 on the other side of the equation in order to show that your acid is double in strength. Hopefully that one makes sense to you. If not, you can skip 10 and 13 and we'll come back to them, but I think they're pretty straightforward. All of the rest of the problems on here have 1-to-1 ratios of acid and base, and you can use the MAVA MBVB equation on every one of them. Good luck, work through the rest of those problems, and we'll look at them the next time we're together.